Let us see the trends in the modern periodic table. The trends in modern periodic table. By trends in the modern periodic table, we mean the variation, the change in some properties of the elements. That is what is meant by the trends in the modern periodic table. The variation of the properties, some of the properties of the elements. That is what is meant by the trends. Let us begin with the valency of an element. Begin with the valency of an element. Say, what is meant by valency of an element? In a general sense, we can say valency is the combining capacity of an atom of the element. It is the combining capacity of an atom of the element. When I say valency is the combining capacity, the picture is not clear for you because you are seeing valency of an element as a number only. So how can we define valency of an element? First of all, remember that valency is determined by the number of electrons present in the outermost shell. Valency is related to the number of electrons present in the outermost shell. Present in the outermost shell of an element. Valency of an element depends on the number of electrons present in the outermost shell of an atom of the element. That's why we say the outermost shell as the valency shell and the outermost electrons as the valence electrons. We had seen that the outermost shell of an atom is known as valence shell. The outermost electrons are known as valence electrons. This is because the number of electrons present in the outermost shell determines the valency of an element. So we say valency of an element depends on the number of electrons present in the outermost shell of an atom or the element. In majority of the cases, valency of an element is the same as the number of electrons present in the outermost shell. In majority of the cases, valency of an element is equal to number of electrons present in the outermost shell. Electrons present in the outermost shell. Say, for example, N, you call it as N, outermost shell. You may call it as N. N is the number of electrons present in the outermost shell. Or it is equal to 8 minus N. 8 minus N. So, valency of an element is equal to number of electrons present in the outermost shell of an atom or the element, or 8 minus N, where 8 is the octet of electrons, as we have seen in the case of the noble gases. Here N is the number of electrons present in the outermost shell. So valency is equal to number of electrons present in the outermost shell of an element, that is equal to N. Or it may be 8 minus N. 8 minus N, that is equal to valency of an element. We can define valency in another way also. Say, we had seen that During chemical changes, metals have a tendency to lose electrons, while non-metals have a tendency to gain electrons. There are certain elements like hydrogen, carbon, oxygen, etc. that have a tendency to share electrons. Share electrons. So we can define valency as the number of electrons lost, number of electrons lost during a chemical change, or it is number of electrons gained, number of electrons gained by a non-metal, or number of electrons shared, number of electrons shared between the atoms. That is taken as the valency number. So valency is the combining capacity, and it depends on the number of electrons present in the outermost shell of an atom. Valency number can be defined as the number of electrons present in the outermost shell n, where n is the number of the electrons present in the outermost shell. That is not the number of the shell. It's not the number of the shell. Now, in the present case, n is the number of electrons present in the outermost shell, or it is 8 minus n. We can define valency in another way also. It is the number of electrons lost or number of electrons gained or number of electrons shared during chemical changes. As we know, in the case of metals, during chemical changes, metals lose electrons. The number of electrons lost from a metal atom, that is the valency number. Similarly, the non-metals have a tendency to gain electron, and the number of electrons gained by a non-metal, that is the valency of the non-metal. In some cases, electrons are shared, and the number of electrons shared, that also is taken as the valency. So valence is equal to number of electrons lost, or number of electrons gained, or number of electrons shared between atoms during chemical changes. It is the same as the number of electrons present in the outermost shell n, or 8 minus n, where n is the number of electrons present in the outermost shell. Say, let us take an example. You take magnesium. Magnesium atomic number is equal to 12. Atomic number of magnesium is equal to 12. You think of the electronic distribution of magnesium. Do you remember the distribution of electrons? In the K shell, there are 2 electrons. In the L shell, there are 8 electrons. And in the M shell, there are 2 electrons. And the M shell is the valence shell. Valence shell. Here, in the magnesium atom, in the outermost shell, the so-called valence shell, there are 2 electrons. 2 electrons. And therefore, the valency of magnesium, that is equal to the number of electrons present in the outermost shell, that is equal to 2. Because during chemical changes, from an atom of magnesium, 2 electrons are lost. 2 electrons are lost during chemical reactions. The 2 outermost electrons are lost from an atom of magnesium during chemical reactions. And therefore, valency of magnesium is equal to 2. See here, the number of electrons in the outermost shell of magnesium is equal to 2, and therefore, valency of magnesium is equal to 2. Or in other words, during chemical reactions, from one atom of the element magnesium, 2 electrons are lost. And therefore, the number of electrons lost during chemical changes, that is again is equal to 2, and therefore, valency of magnesium is equal to 2. So, number of electrons in the outermost shell or number of electrons lost during chemical reactions, that is valency, and here in the case of magnesium, that is equal to 2. Similarly, you take sulfur. Atomic number of sulfur is equal to 16, and there are 16 electrons. There are 16 electrons. You distribute the electrons as K shell is equal to 2 electrons, L shell is equal to 8 electrons, and M shell that is equal to 6. Say that is equal to 6. Now, valency of sulfur, that is equal to 2. Valency of sulfur is equal to, here it is 8 minus n. 8 minus n. That is equal to 8 minus 6, and that is equal to 2. That is equal to 2. So valency of sulfur, so non-metal, sulfur, that is equal to Q, that is 8 minus n, where n is the number of electrons present in the outermost shell, which is equal to 6. During chemical reactions, one atom of sulfur gains 2 electrons. One atom of sulfur gains 2 electrons. So the number of electrons gained by one atom of sulfur, that is equal to 2. And therefore, valency is equal to 2. I had defined the valency in 2 ways. That is number of electrons present in the outermost shell, or 8 minus number of electrons in the outermost shell. Either number of electrons present in the outermost shell, n, or number of 8 minus number of electrons present in the outermost shell, that is 8 minus n. And I have defined valency in another way also. That is number of electrons lost from one atom of the metal, or it is number of electrons gained by one atom of the non-metal, or it is number of electrons shared between atoms. That is valency. And here magnesium, in the outermost shell of magnesium, there are 2 electrons. So immediately we can say valence is equal to 2. And during chemical reactions, from one atom of magnesium, 2 electrons are lost. So the number of electrons lost from one atom of magnesium, that is equal to 2. Therefore, valence is equal to 2. We have seen that reaction, Mg plus 2 ion is formed. When 2 electrons are lost, Mg plus 2 ion is formed. That we had seen when we are dealing with the ionic bond. Then come to sulfur. There are 6 electrons in the outermost shell. And in this case, valence is equal to 8 minus n. 8 minus 6, that's equal to 2. So the valence of sulfur atom is equal to 8 minus number of electrons in the outermost shell. That is equal to 2. Not only that, during chemical reactions, one atom of sulfur gains 2 electrons, forming S minus 2 ion, sulfide ion, S minus 2 ion, and therefore valency of a sulfur is equal to 2, number of electrons gained. I shall show in the case of magnesium, during chemical reactions, say magnesium, from magnesium, 2 electrons are lost, plus 2 electrons. 2 electrons are lost, forming Mg plus 2 ion. Therefore, number of electrons lost is equal to 2. Therefore, valence is equal to 2. Come to sulfur. Sulfur. Say sulfur, it combines with the 2 electrons plus 2 electrons, giving S minus 2 ion, sulfide ion. S minus 2 ion, sulfide ion. So when sulfide ion is formed, 2 electrons are added to sulfur. Sulfur gains 2 electrons. So the number of electrons gained by one atom of sulfur is equal to 2, and therefore valency is equal to 2. So we can explain valency related to the number of electrons present in the outermost shell, and therefore the outermost shell is called the valence shell. Let us see this again. So valency of an element, Krishna, Avishi, Aisha, Anna, Anne-Marie, Vinayak, Nafia, Atulya, Jyoti. I believe that all of you are there. You are not sleeping. You are there? If you are there, you will respond. Irene, Pavitra, Jyoti, all of you are there. Okay. So valency is determined by the number of electrons present in the outermost shell of an atom of the element. That is determined by the number of electrons present in the outermost shell of an atom of the element. That's why the outermost shell is called valence shell. And the number of electrons present in the outermost shell is known as valence electrons. The outermost electrons are called valence electrons. The outermost shell is called the valence shell because the number of electrons present in the outermost shell determines shell. If n, small n, is the number of electrons present in the outermost shell, then valency is equal to either n or 8 minus n. For example, you take metals. In majority of the metals, the valency is equal to the number of electrons present in the outermost shell. Then non-metals, it is found to be, majority of the cases, it is found to be 8 minus n. 8 minus n. We can define valency in another way also. During chemical reactions, metals have a tendency to lose electrons. The number of electrons lost from one atom of the metal, that is taken as the valency number. The non-metals always have a tendency to gain electron, and the number of electrons gained by one atom of the element, that's called valency of the non-metal. We have seen during the formation of the covalent bond, there is sharing of electrons. So the number of electrons shared by the atoms, that is also valency of an element. That depends on the number of electrons present in the outermost shell. Okay. We have taken 2 examples, magnesium and sulfur. Atomic number magnesium 12. 282, that's the configuration. 282. Outermost shell, there are 2 electrons. So the valence of magnesium metal is equal to 2. And during chemical reactions, from one atom of magnesium, 2 electrons are lost. We have seen Mg giving Mg plus 2 ion plus 2 electrons. So when Mg plus 2 ion is formed, 2 electrons are lost. So a number of electrons lost, that's equal to 2. So valency of magnesium is equal to 2. Another example taken, sulfur. 16 atomic number, 286. 286. Here valency is equal to 8 minus 6, that's equal to 2. During the formation of a sulfide ion, S minus 2 ion. Sulfur atom gains 2 electrons. S plus 2 electrons giving S minus 2 ion. So a number of electrons gained by one atom, Buddha. So a number of electrons gained by one atom of sulfur, that is equal to 2. Faiz, Faisal, Nafia. Okay, so number of electrons gained by one atom of sulfur, that's equal to 2. Therefore, valency of sulfur is equal to 2. Okay, you follow this or not? Followed. Okay, so let us think of the variation of valency. You take a period as well as a group. In a period, you take a period. Say in a period from left to right, how does valency change? How does valency vary? In a period, you take one period, any period, period 2 or period 3, you take. From left to right, we can see that the valency increases from left to right. Valency increases, it increases. Valency increases from 1 and it reaches to a maximum 4 in the fourth group and then decreases. That is the change. And then decreases. The question will be like this. How does valency vary across a period? How does valency vary across a period? So across a period, from left to right, valency increases from 1 to 4, reaches a maximum towards the middle of the period, and it is 4, and then decreases. Valency decreases. You take, for example, say period 2, you take a period 2. One example, you take a period 2. Period 2, do you remember the elements in period 2? Period 2, remember? Second period, elements in period 2. The elements in period 2 are, say, one is lithium, then beryllium, 5 boron, carbon, nitrogen, 7 nitrogen, 8 oxygen, then fluorine, and there is the neon also. It is there. Valence is equal to 0. So you can see that the valency, lithium is equal to 1, beryllium is equal to 2, boron is equal to 3, carbon is equal to 4, nitrogen is equal to 3, oxygen is equal to 2, and fluorine is equal to 1. See, from left to right, across a period, from left to right, valency increases, reaches a maximum 4, and then it decreases. That is the trend of valency in a period. You take any period, second period I have taken as an example. You can take the third period also. There also you can see this trend. Valency increases from left to right, from 1 to 4, reaches a maximum at 4, towards the middle of the period, and then it decreases. The question is, how does valency vary in a period? So in a period from left to right, valency increases, reaches a maximum 4, and then it decreases. Okay. Let us think of the valency in a group. How does valency vary in a group? You take a group. Say, for example, you take a group 1, alkali metals. You know, the elements are group 1, lithium, sodium, potassium, rubidium, cesium, and francium. These are the elements in group 1 alkali metals. Do you remember the electronic configurations of these elements? In a group, say for example, this one you take, this one, group 1. In the outermost shell, there will be, I shall take one example, lithium. Atomic number of a lithium. Do you remember? That is equal to 3. So what will be the configuration? In the K shell, 2 electrons. In the L shell, 1 electron. Okay. Am I right? You take one more example, sodium. Atomic number 11. 11. In the K shell, 2 electrons. In the L shell, 8 electrons. In the M shell, 1 electron. Then you take potassium, atomic number 19. In the K shell, 2 electrons. In the L shell, 8 electrons. In the M shell, 8 electrons. In the N shell, 1 electron. So what do you see here in common? There is something common here. Can you find it here? Something common is seen in this case. What is it? You see this one? See? What is common there? Asif? What is
Balance.
a group? In a group, in the
Outer shell.
there will be same number
1.
of electrons. There will be same number of electrons in the outermost shell. In the valence shell, there will be same number of electron. In a group, in a group, in the outermost shell, there will be the same number of electrons. And so, what you can say about the valency, Shabari? There is a same number of electrons. So, what about valency? What do you expect?
It will be also the same.
Valence is related to the number of electrons in the outermost shell. Here, number of electrons in the outermost shell, that's equal to 1, the same. And therefore, in a group, there is a common valency, there is same valency. In a group, there is a same valency, What the reason? The reason is this, because same number of electrons in the outermost shell. In the outermost shell, in the valence shell, there will be the same number of electrons. And therefore, in a group, there is a common valency, or in other words, the elements in a group have the same valency. For example, you take group 1 alkali metals. In the outermost shell, there is only 1 electron, and the common valency is equal to 1. Alkali metals, group 1, that is equal to 1. You take group 2, for example. Group 2, say, which are the elements in group 2? Do you remember the elements? Beryllium, then magnesium, calcium, strontium, barium, radium, etc. You take beryllium, for example, atomic number is equal to 4. In the K shell, 2 electrons. In the L shell, 2 electrons. 4 electrons. Totally 4 electrons. Magnesium, that is equal to 12 atomic number. In the K shell, 2 electrons. In the L shell, 8 electrons. In the M shell, 2 electrons. Then calcium, that is atomic number 20, and K shell is equal to 2 electrons. L shell is equal to 8 electrons. Then M shell is equal to 8 electrons. N shell is equal to 2 electrons. Group 2. See the relation between the number of electrons in the outermost shell and the group number. Group number. So there is a relation between group number valency and number of electrons in the valence shell. So in group 2, magnesium, calcium, strontium, etc. In the outermost shell, there are 2 electrons. 2 electrons. Same number of electrons in the outermost shell. So in this group, there is the same valency, a common valency, and that is equal to 2. So in general, we can say the in a group there is a common valency. The elements in a group have the same valency. Why? Because number of electrons present in the outermost shell, that is the same. Okay. You take a group 17 halogens. Group 17 halogens. Which are the elements? Which are the elements in group 17 halogens? The elements are fluorine, chlorine, bromine, iodine, and astatine. These are the elements. You take 2 examples, fluorine and chlorine. Atomic number of fluorine, do you remember? That's equal to 9. So in the K shell, it's equal to 2 electrons. In the L shell, there will be 7 electrons. Chlorine, atomic number 17. In the K shell, 2 electrons. In the L shell, 8 electrons. In the M shell, 7 electrons. M shell, there will be 7 electrons. See here, in group 17, see here, 17. In group 17, the number of electrons in the outermost shell, that is equal to 7. And valency is equal to 8 minus n, that is equal to 8 minus 7, that is equal to 1. Valency is equal to 1, that is equal to 1. So the elements in group 17 halogens, they have the common valency 1. That is also due to the same number of electrons. So let us generalize this. Let us take this again. So how does valency vary in a period? In a period, how does valency vary in a period from left to right? Valentina, how does valency vary in a period from left to right? You simply say whether it increases or decreases.
Increases from
Valentina, valency in a period from left to right. You are saying something or not?
increases.
Adi? Valency in a period.
Increases from 1 to 4.
It increases from left to right, reaches a maximum 4, and then decreases. It is not continuously increasing. There is another way also to define valency. According to our text, you say valence increases from left to right, reaches maximum 4 towards the middle of the period, and then decreases. And what about the variation of valency in a group? Aditya? Adi? In a group,
Atomic size increases.
the elements have a same valency, a common valency. That is because the elements in a group have the same number of electrons in the valence shell. Same number of electrons in the valence shell. For example, group 1, alkali metals, valence is equal to 1. There is only 1 electron in the outermost shell. Only 2, 5, 8, 10, 11 students are there. 43 are there in your batch. There are 43 students in your batch. See, so let us continue. So the trends of valence will be like this. In the group 1, alkali metals, there is a common valency because the number of electrons in the outermost shell is equal to 1. It's equal to 1. Valence is equal to 1. Group 17, there are 7 electrons. So you remember at least the fluorine and chlorine. there are 7 electrons in the outermost shell. And valency 8 minus 7 is equal to 1. Group 17 halogens, valency is equal to 1. So in a group, the elements have a common valency, the same valency. That is because, what is the reason? Asif, in a group, the elements have the same valency. Why? Why the elements have same valency in a group? Valency is related to a number of electrons in the outermost shell. And I say, in a group, there is a same valency. Why? Asif? Okay, in a group, the number of electrons in the outermost shell is the same. So they have the same valency. I took only 1 point. I decided to finish this chapter today itself, but I could not. Say, you must cooperate with me, then only I can finish the classes. I can